Hello everyone, and welcome to today's webcast on predictive maintenance, brought to you by Plant Services and Infor. I'm Tom Wilk, Chief Editor of Plant Services, and I'd like to express our appreciation to you for joining us today. This webinar is sponsored by Infor. With 14,000 employees and customers in more than 200 countries and territories, Infor automates critical processes for industry. The Infor EAM asset management solution gives you the power to improve capital asset management in ways that increase reliability, enhance predictive maintenance, ensure regulatory compliance, reduce energy usage, and support sustainability initiatives. This is the second of several 2017 webinars which feature original research conducted by Plant Services on topics that our readers tell us they want to know more about. We hope you enjoy this webcast on predictive maintenance and that you consider joining us later this year for a webinar on electrical safety, which will also draw from original research. Before we get to the speaking sessions, there's a few housekeeping issues that we should review together. On your screen, you should have several primary sections. The upper left or audio section allows you to adjust the volume of this presentation. Just hover over this section until you see the audio volume control and adjust it to your preference. At right, in the largest section, is where today's presentation slides will be displayed. Under that slide window, you will see a group chat section where you can chat live with fellow audience members. At the left of the slide window is the Ask a Question box, where you can type a question for the presenters at any time during today's webinar. I want to say hello to Carl Dupolt, who already said hello to us via the Q&A box. We'll get to those questions during a live Q&A session following the second presentation. The handout section at the bottom left contains links to several resources, including both sets of presenter slides, a PDF download of the full data set for the 2017 Plant Services PdM survey, which is exclusive to live attendees today, and 4 handouts from Infor plus a link to their homepage. Their handouts include 2 customer case studies, a video on best-in-class asset management software, and a brochure on Infor EAM. Finally, at the bottom of your screen, you should see icons for additional features. By hovering over each icon, information about that icon will be displayed. If you're having technical problems, you can type your question or concern in the Ask a Question box, and one of our technical engineers will assist you. Do you need a better view? Enlarge a section by clicking on the box in the top right corner of the section next to the X. This may be especially germane today, as much of the PdM survey presentation will consist of tables, so feel free to enlarge that for better viewing of those tables. If you accidentally close out a section, you can get it back by clicking the Restore button at the bottom of the screen. It's the far left icon in the shape of a double arrow in a circle. This webinar will be archived, and we encourage you to direct coworkers to the on-demand presentation. Finally, at the end of today's presentation, we'll ask you to complete a very brief survey to provide feedback that we can use to improve these webinars. At this point, I'd like to move into the presentation part of the webinar. In a few minutes, we'll be joined by Kevin Price, who will present on how predictive maintenance software can help your organization build a clear line of sight to preventing problems and delivering more profitable results. Before Kevin speaks, however, I'd like to start this webinar by reviewing with you several key findings from the Plant Services 2017 Predictive Maintenance Survey. Findings which point to a change in attitude since the last survey we did in January, February 2016. But it also fits into some findings from the 2017 Workforce Survey over concern where new talent is going to come from to drive predictive maintenance programs. So some of these data were presented in the cover story for our April issue called PdM Balance. I'd like to start this presentation, though, with a quick slide defining what predictive maintenance is. If you were with us last year, you may remember this slide. It is comprised of 2 things. It's a strategy based on measuring the condition of equipment and then taking appropriate action. And again, it's useful to keep those 2 sides of the PdM coin in mind, because I think that between those 2 sides is where a lot of PdM programs stall, fail, or otherwise lead to less satisfactory results. It's not just collecting and measuring data, it's taking action to avoid consequences. And the condition of the equipment can be measured using condition monitoring, statistical processes, control, equipment performance, and human senses. So a wide variety of data, not just your classic condition monitoring data. Last year we did an extensive look into PdM, leading with the 2016 version of the survey, soliciting industry response to that survey, and then following up later in the year to answer questions that we heard from readers and attendees like you along the way, which was, what do you do when your predictive maintenance program stalls and it's, for whatever reason, whether it's employee turnover, whether it's insufficient results, insufficient ROI, or an inability to calculate the financial returns. So we did a double cover story in September, October to investigate what do you do to fix programs. This slide shows the historical series on predictive maintenance research and plant services, including all 6 key stories from last year. The last 2 of those stories represent the what do you do when your PdM program needs a restart. And also 3 links to the 2017 cover story. And these 3 topics is going to be how this presentation is structured. From here on out, we're going to be seeing a lot of tables, but we're going to take them in order. Number 1, address plant culture to support predictive maintenance programs. In other words, who makes the decisions. Then we move into the second part, which is more about the technologies being chosen and how they're being applied. What are these people deciding? And then finally, a third section, which is who sees the data, both inside and outside the plant, and how happy are they with those data. So moving to the first table, we always start these surveys with this basic question, so we have an understanding of who is responding to these questions. What is your primary job function, right? And I think that you see a very clear trend over the past 3 years, from the first time we did the survey to the one we did earlier this year. You've got a drastic drop-off in the number of plant managers and plant engineers, and you've got a concomitant rise in the number of reliability engineers, reliability technicians, and maintenance engineers. So what does that mean? Well, we've got a few tables to follow which might put some context around this. One indisputable finding, though, is either there are fewer plant managers or fewer plant managers taking these surveys. After seeing the results of 4 surveys over the past couple of years where we've asked this question, I'm pretty sure that at least when it comes to our audience has changed, the respondents have changed, but this trend has stayed the same. There's simply fewer plant managers out there and a lot more newly minted reliability engineers and reliability technicians. The question is, who is responsible for what these days when it comes to making the decisions and justifying the results of programs like a PdM program. A little further background on this next table, you see who makes the decisions. And for the first time, you see in this survey that Generation X, there are more people who, let's see, baby boomers are for the first time in a clear under 50% minority of the respondents, which even 2 years ago wasn't the case. So, you know, when you do think about the results of the PdM survey and trying to figure out what these data mean for you and your organization, always keep in mind that the data from even 2 years ago was much more heavily influenced by folks who were either on their way out the door, retiring, or who are now staying on as consultants, and that you've got a lot of younger workers coming on board. The next finding in this slide is when it comes to job title breakdowns, you see that again, the decline in managerial professionals taking these surveys and an increase in the frontline professionals taking these surveys. So as you see these data, again, you're getting data from the people who are actually on the floor, handling the equipment and handling the assets. Finally, if you separate out the other lines on the job title breakdown, which more or less stay the same, you do see the plant manager role dropping the most, and you do see the maintenance reliability role increasing the most. One more contextual question. How many total plants does your organization manage? And again, in the past 3 years, you see 2 to 5 and 6 to 15 staying about the same, but you do see a lot of single plants, either closing or being consolidated and being bought out, which to me might explain at least some of the reason for the decline of the plant managers. Either plants are consolidating and plant managers are moving to different jobs, retiring, or otherwise departing from the plant. So let's move on to the guts of this presentation. What decisions are they making? And this is usually the slide which gets the most immediate attention. What PdM technologies have you deployed? And again, I apologize if you've got the slide window in its normal size, you may want to click on that small box in the upper right to expand it if you want a better, if it's easier for you to see the numbers that way. I'll put a few boxes on these numbers to highlight what we think we're seeing on the plant services side. One trend, which has stayed the same, is that you've got what we refer to as the big three, or the common three predictive maintenance technologies: vibration, infrared, and oil analysis. Seem to form the three legs of the PdM stool. Usually people are using one, two, or all three of these as they get programs going. What we're hearing more and more is that you've got the fourth one, which is on the rise, ultrasound. And I've got an interesting anecdotal story about ultrasound and what might be happening when it comes to these PdM technologies. I met an electrical maintenance manager at the reliability reliable asset event in Clearwater, Florida. And this person said he came to the ultrasound conference because his finance team had approached him and said, look, pal, we know that you're using infrared for condition monitoring, your basic condition monitoring and predictive maintenance techniques, but we've been approached by our insurance provider who said that the rates will go up next year unless we can prove to them that the condition monitoring results are sound and reliable by having a complementary technology to back up the results. So, you can take a look at your organization and ask yourself, what might be driving these programs? Is it a concern over EH&S, a reliable plant is a safe plant? Is it a concern from the finance team to help mitigate the risk in your organization's portfolio? Whatever the reason, we are seeing PdM technologies deployed in complementary fashions because, again, this isn't a one-size-fits-all exercise. Different PdM technologies are going to be appropriate for different assets. And sometimes two or more of those technologies can help you understand the single asset better. Adding a new box here, this was the most surprising result to me. This time last year, I went on a webcast, and someone said, what do you think is going to be the technique that is embraced the most greatly in the coming year? And I said it was predictive modeling, because you saw an 8% spike from 2014 to 2016. Well, looks like the big wheel turned down from 2016 to 2017. There was a decline in predictive modeling techniques, which says to me that people are more comfortable using a more hands-on approach, and who really knows what the explanations for the decline in predictive modeling software might be? I know Kevin probably has some thoughts on that. He'll present on predictive maintenance software near the end of the session. One possibility that I've heard when I was asking a couple of folks about this was that it might be simply that IT teams can be hard to work with. So people simply say, I'll use technologies which let me have the least amount of contact with IT. Again, food for thought. Write your questions down as the presentation goes on, and Kevin and I will do our best to answer them as we go forward. I do want to add one last green box here. That you see within 3 years, the number of people who are saying that they're going to kick the can down the road really declined after mixed results from 2014 to 2016. You do see in 2016 and 2017, people aren't making their decisions. They're getting off the fence, and either doing it now or later this year, or they're not going to do it at all. Now that may change from year to year or 2 years to 2 years, but I think it is interesting that the concept of a more proactive maintenance stance via predictive technologies and their complementary condition-based technologies are really penetrating the consciousness of plant teams. And perhaps this does reflect the rise in reliability engineers. So if you look at this slide, what decisions are they making? And what type of assets are managed by PdM solutions? This is usually the second most popular slide. How are people actually applying these things? And so I'll add a few boxes right here. The top applications continue to be production assets in electrical systems. And to add the dotted blue box, you see an uptake in people applying it for distribution pipelines, which also reflects a rise that I think we're seeing in attention to PdM techniques that measure corrosion. I also want to add this red box right here, which backs up what we were looking at before in the previous slide about are people on the fence or not. You can see here in 2017 they either are or they aren't doing it. It's not a whole lot of waffling, especially when it comes to distribution pipelines. You can see far more people expressed interest in focusing on pipeline corrosion and other issues related to pipeline health than previously. I think production assets is about the most stable one, where about 11 to 12% said no, we're simply not going to do it. For the rest of the category, people said yes, we are, or no, we're not. This slide, again, I know that the data points are kind of small, so feel free to enlarge the slide box on your computer. What type of assets are you using internet-enabled or IIoT technologies to manage, as opposed to simply predictive technologies? And you see a pretty sizable jump when it comes to control system assets, which makes sense, they're already networked, and electrical systems, with automation assets in a distant third. These numbers here match our general sense of what the market penetration for internet technologies is. There are still a lot of pilot programs going on. People are trying things to see if they work. And there's not a single platform to deploy internet-based technologies that seems to have won out over the others, such as Predictive, for example. So again, we're still in the experimentation phase, and I think a lot of people on this webinar are interested to hear from customers who are having successes when it comes to digital transformation initiatives. So this slide is also a favorite of mine. It's what data collection methods do you currently use with your PdM program? And on top, for the third year running, is still a paper-based system. So these questions were not mutually exclusive, right? So we asked people to choose all that applied. So it's not that 62% this year, or 60%, close to 63% are using paper and nothing else. It's just that 63% of people this year said they were using paper, 59% said handheld data collector. I'm really curious at the point when those two curves are going to cross, and we're going to see some digital method of measuring on top of the manual paper-based system. As it is right now, if you're still using paper, you're not alone. A lot of people still are. But I think, interestingly, across the board here, too, we saw modest declines in everything from smartphones to tablets. Industrial-grade PC was about the only one that showed a modest increase, besides handheld data collectors. And also, embedded, I'm going to add this box here, wireless sensors went up significantly as well. So you got a lot of folks experimenting with the kind of sensors that are battery powered or wireless and or wirelessly enabled to keep a continuous stream of data flowing. And you see embedded sensors declining, which I think is interesting because to me, part of what embedded sensors mean is OEMs being able to access data. And we'll see what people think of that in a few more slides. I do want to mention out loud, before this webcast began, Kevin Price and I were talking about usability. And that conversation immediately fit this set of data specifically, which is, it raised the question in my mind, what if the user interface on these predictive maintenance apps is simply too difficult to use or people find a difficult time using them? To what degree does UX matter? So I'm going to put that out there and ask the attendees, in your experience when you use these apps, what has been your reaction to predictive maintenance apps on phones and on tablets, and I'm sure that Kevin and I will pick up the discussion later on. Moving to the next slide. Who uses the information provided by your PdM systems and with what frequency? I'm just going to slap the bright red box up right away. Very few people like sharing their data outside the plant for whatever reason, whether someone told them not to, whether they are uncomfortable sharing the data, whether they think the data is too valuable. It's just not a common practice yet. Despite the fact that a lot of services, such as machine learning, advanced analytics, a lot of third parties can come in and see things in the data that plant teams might not have the expertise to handle. Plant teams are still reluctant to share this data. I'm going to put some green boxes up here. If you see, the highest number of folks to see the data was reliability engineers and maintenance engineers in-house, who saw them most often and weekly. And I'm going to throw a couple of blue boxes up, which I was surprised by. If you look in the far right column, this year's results, 2017, who sees the results most often on a quarterly basis? It's not the in-house maintenance, it's not the in-house reliability engineer, since they see it weekly. It's the in-house operations team, which a generous number of people see it weekly and monthly too, and also the OEM supplier, which again, I can't say this is completely surprising given how many OEM embedded sensors there are in equipment, but it is interesting to note that in the end, when you get past weekly and monthly data sharing, the quarterly data sharing actually goes more often through different teams. I do have one anecdote to tell about data sharing outside the media organization. It's a soda ash refinery operation in Wyoming who presented at 2 different events this year about their inability to perform a root cause failure analysis effectively on a piece of grinder equipment which kept getting jammed with particles that were too large to be ground down. So they enlisted the help of a third-party data historian and they also enlisted the help of a third-party data analytics firm. Take a look at what's happening. And after they had added timestamps on the data for 2 months, and they had started to use advanced analytics to weed out the nominal data where there were no special events happening, no stoppages, no problems, they started to see a pattern. And the result was that this third party was able to come back to the original organization and say, you know what, there's not a single root cause. It's actually a process problem. It's not an equipment problem. It's a process problem where you have 2 conditions happening before the ash gets to the grinder, which is generating larger particles after they were supposed to be sifted out. So that story was compelling to me because, number one, it was an example of data sharing internet technologies making a difference in program success, but also by enlisting the help of a third party and letting the data leave out the walls of the plant, the team discovered it was a process issue, not a single point of failure, which they otherwise probably couldn't have seen. So one last point in this section of what decisions are they making, we simply said, given the rise of a new kind of maintenance, prescriptive maintenance, the kind where you do use outcome-based analytics, where you run the results of taking different kinds of action based on the problem that's detected to find out what the different outcomes will be, such as, do I have to fix, if I wait 2 weeks to fix this, will it break down? If I wait 4 weeks to fix it, will it cost even more damage? If it lasts 6 weeks, can I time that repair with my planned shutdown? We see 15.3% of people saying they are already experimenting with outcome-based, diagnostic-based maintenance beyond simple detection of an issue ahead of time, diagnostics ahead of failure. The largest swath there is still preventive. Again, I think that it should be because much of the maintenance in the plant does not necessarily have to be predictive. If you listen to people whose best practices are recommended that you do a criticality analysis and deploy predictive and prescriptive on your critical assets, and then do route-based or time-based maintenance the rest. This chart lines up with that. But it's always interesting to see this new form of maintenance. 15.3% of people are already experimenting. So I have 3 more slides to go on this. We'll breeze through them quickly, and then we'll get to Kevin's presentation. If you look at this slide, please rate the performance of your PdM program over the past 12 months. A year ago, we had a lot of unhappy people. And this year, we have more happy people, at least more satisfied people. About 10% more people think their program is either effective or very effective, and the numbers who thought it was satisfactory have also gone up too. That was a big concern last year, where people were reporting that they were simply unhappy with what's going on, even though they had money to spend on the programs. I just want to point out that the bottom 2 categories have declined over the past year. So good news for those of you who are achieving success with PdM. Please rate the obstacles limiting success of your initiatives. Just want to call out 4 data points. These 2, where people say not enough budget. Seems like it's a chronic issue. And then these 2 boxes, which say limited engineering resources. Now, I thought this data point was interesting given some of the data we got from a workforce survey that we ran about in November, December of last year. So people are reporting that they don't have enough resources to get the job done. That could mean training. That could mean just sheer number of people. So I pulled over a data table from that workforce survey in which we asked frontline workers, operations, maintenance, reliability, engineering, production consultants, what do you think are the biggest challenges to workforce change? Taking as one of my assumptions that successful PdM programs did signify a certain cultural change from reactive to proactive mode. If you look at these red boxes, overwork due to lack of skilled workers and lack of access to training. So again, these results back up the previous slide, which said that limited engineering resources were one of people's primary pain points when it came to PdM. I also want to point out this next one too. 2 more red boxes: lack of follow-through at the manager executive level, and lack of direction, communication from executive level. People don't seem to trust that their managers are communicating effectively or supporting them. And this final slide sort of brings it all together. What certifications does your company invest in? It cuts across training, it cuts across communication, and half of the people surveyed said that they are not being invested in certifications. So again, we see some progress in PdM programs. We see different technologies being deployed, more of them, more frequently. We also still see this tale of 2 cultures, where you're either a plant that gets it or a plant that doesn't. So with that, I'm going to go to my last slide and think of your questions, write them down. I'll be watching the Q&A box. At this point, I'm going to transition over to Kevin Price, who is a Senior Product Director for M4EAM. Kevin has more than 20 years of experience in the Enterprise Asset Management Solution area for M4, and he has served in multiple leadership roles in sales, service development, and product management. He is currently the Senior Product Director for M4EAM Portfolio, which includes EAM Enterprise, MP2, Energy Performance Management, and Spirit Technologies. Kevin is based out of the M4EAM Development Hub in Greenville, South Carolina. And Kevin, thank you very much for being here today with us.
Tom, thank you so much. Being able to see the quantified information that you presented, being able to hear the inferences that you made, being able to see also what folks are doing in the market is so important, because for us to be able to really understand where predictive maintenance can go, it helps to understand what others are doing. It helps to understand what the market's doing. It helps to understand where the generations are putting focus, where different verticals are even putting on focus. So thank you for sharing what you did. Looking at predictive maintenance for us has always been something that we pride ourselves on. When you look at asset management evolution, you look at many different approaches. You look at reactive maintenance, fix it when it breaks. Preventive maintenance, every so often, every so many hours, every so many miles, every so much day. You're looking at predictive, man, that's when you start to get into things that are really, really impactful. Why? Is because you understand your assets more. You understand the vertical that they're in. You understand the technology that's involved into it. You understand the true impact that you can make. To do that, however, the practicality of getting there, that's the hard part. To do that, you need to spend an inordinate amount of time, one would seem. Some areas, not so much, but some areas it's pretty intensive to understand where your assets are, making a register of them so that it makes sense, being able to have a very logical and clean infrastructure to be able to look at how those assets are identified, how their relationship works within how they operate, how they're named, different types of clean ways in which you can be able to segment out detail like documentation, being able to have videos on them as much as you can. These are things that you have to start out with. Having a clean environment for asset management is your true method to be able to grow that. Looking at it a little bit further, once you have this type of information, the next type of thing is really to understand the nature of that asset. What is its job? What is its role? What happens if something breaks? Who's affected? Operators, environmental conditions, these different types of stakeholders that are involved may be people that you don't know off the top of your head. If you're looking at a transit provider, for example, and you're looking at the stakeholders that are involved in that process, well, if the bus doesn't get there, who's upset? The people that need to get to work, the people need to get to school, the people need to go out and do their errands on a daily basis. They can't do it. What about the drivers? The drivers are upset too because now they're going to miss their schedules. They're going to be in a rush. It's going to be difficult to move around. What about the maintenance operators? The worst thing that can happen is that bus actually breaks down in the middle of the city somewhere, and you have to go chase it and pull it down. You have costing elements that go in. You have embarrassing elements that go in because they're looking at that bus and the logo that's associated with. So there's a lot of different people that are involved in a failure that may happen to an asset. So understanding what its role is in life in your organization, being able to understand what would happen if it actually failed, gives you a good understanding of the nature of that asset. The next thing to do is to take that knowledge and quantify it. Take that knowledge and understand what the likelihoods of it failing are. When it would in the beginning, when it would in the end. Everything over time depreciates. Everything over time becomes more expensive to be able to maintain. I have a car that I've had for a very long time that has several 100,000 miles on it because of maintenance activity. Now, the maintenance that I did in the beginning is a lot cheaper than the maintenance I'm doing now, but it can be maintained. The question is, should it? Once you get that, you can be able to understand what type of risk value or analysis you're putting on top of it. And it's good ways to be able to take that into a little bit more of a approach of cross-section, being able to understand what the severity of that particular failure is and the likelihood of it occurring. There's lots of different ways to be able to plot your risk analysis on an XY like this. Some things may be the risk of failure happening and the impact that it has to your business. So as an example, a light goes out in your office, no problem. It's something that breaks, you can't see, but you'll survive because you can go continue to do your work. You have a screen that has a line and everything's okay. What about your executive? What happens when his light goes out or her light goes out? You're now in a world of hurt because that's not supposed to happen, or even worse. What about a neon sign that has your company logo on it and one of the letters goes out and doesn't produce a word that's exactly what you thought it would be? The risk analysis takes on many forms. The risk analysis helps you understand, again, the nature of that asset, but also the impact that it has to your organization. It helps you understand how to be able to maintain that asset. Do you want to put a tremendous amount of preventive maintenance schedule into changing my light bulb in my office above my desk? Maybe not. Maybe when it goes, I send a note out, they'll come to replace it. But again, if it's a neon sign that goes out, these are things that you can be able to do preventive maintenance actions for. These are things that you can be able to make sure that they don't happen. You don't want bridges to fail. You don't want buses to crash. You don't want equipment to shut down. You don't want platforms to explode. These are types of things that have different risk variables. Understanding that asset helps you bring about the best type of practice you have for it. What types of predictions are you going to involve? Are they going to be quantitative elements of of calculations that are based on things like oil analysis, vibration analysis, are the things that need to have automated influx of condition, where you bring in meters, monitoring systems, SCADA systems, project logic control systems to tell you what condition that they're in. That's where the IoT comes into play in a big way. Once you have that information, though, can you focus your efforts? Can you put them in the right place? Can you help prioritize in the right way? All of these things need to be built based on what that asset does, how it lives its life, why it lives its life, the impact that it has to the organization, and more specifically, the negative impact that happens to the organization when it doesn't do its job. Once you understand a lot of that, then you can start to take the elements that surround it. So being able to understand that asset station, what's involved with it, and when it fails, I need to have certain types of people, you have to have all of that brought in. If you're going to maintain an asset until failure, do a reactive mode of maintenance, then you need to be able to have different types of people employed. There's certifications that need to be brought up. You need to have who's available when so I can bring it in. If you're doing predictive modeling, that involves risk analysis, reliability components, reliability concepts. Reliability engineers is who you need to be able to monitor that asset. Or telemetry information, metrology information. If it's calibration elementary that goes in, you need to have calibration engineers available on that asset, knowing that asset, living that asset, breathing that asset, being able to make sure the people who are scheduling that person are on top of it. There's a lot that's built into that asset once you identify its nature. Once you identify what it's like to be able to keep that going. Being able to make sure you have the people that are available, ready, and able to be able to work on that asset, not only from a qualification perspective, but from an availability perspective. Because if something does happen to that asset, you don't have the right people available, you don't have them scheduled, the predictability of when that asset is going to fail does not have the people to fix it because it's just simply not there. What happens to that downtime? What happens to that embarrassing event where the sign goes out wrong? What happens when that vehicle is out in the city and the logo is staring at the face and people are taking pictures on their phone and then putting it out to Twitter? These are not things that you want to be able to have. So understanding it and making sure the elements that are around it are scheduled in a good way is the most important. That means you need to plan in a different way. Being able to understand condition in a different way. Being able to schedule in a different way. Being able to have the right skills, the right detail, the right materials, perhaps a new definition of redundant bill of materials available for the asset is in order. Being able to look at plans and how they're built in. Being able to have access to schematic drawings at the right time, the right place, in the right way. Mobile devices help with this, right? Being able to see an asset, being able to pull up a schematic, being able to pull up an OEM manual. These are things that you want to have in your organization with ease of access for assets that matter. Again, if it's looking at doing maintenance, and the maintenance in this example could be something that could be landscaping, wanting to make sure that you have the grass cut in a certain way, may not make a lot of sense in an organization that is a distribution facility. Making sure that the grass is cut down so that you can be able to have a good, clean environment is important, but maybe not paramount. What about making sure grass is cut on a runway? Or making sure that the lights, again, don't go out on a runway? These are things that are FAA reportable events. So focusing your efforts where you have the highest risk, where you have the highest exposure is important. But it's equally as important to be able to make sure you put where you have the largest opportunity. Making sure that asset's available, making sure that you're doing the right thing is also a definition of focus. Being able to do the right things with those assets, being able to have it be as healthy as it can be in an environment where it breaks down and not only damages materials that may be works in progress or materials that affect the performance is one thing, but also looking at damaging people around it, the different personnel, the different operators. These are things that you have to pay attention to and the decisions that you go through on a regular basis. Once you understand that, once you understand that you have the right people, once you understand that you have the right material, once you understand that you have the right risk variable, now is where you start scheduling. You start being able to make sure that you're doing the right thing at the right time with the right people in the right way. Production environments, perfect example. You only have a certain window in which you can be able to do maintenance. Shutdown is only done in a certain way. Some manufacturing line assembly plants, for example, they go down, they can now be so highly flexible that they can be able to take an entire product line and reconfigure a line so fast that you can run down a new product in a matter of hours, if less. These are things that you have very small windows to schedule into. So you need to make sure that your data is clean. You need to make sure that your risk is understood. You need to make sure that your material is available. Your education is on par. Your permitting is on par. Your access to the information is on par. And you have the right tools to schedule it to get it done. The concert of working with regular asset management and working with production-oriented issues, capabilities, people may not always have access to this information. Being able to collaborate in a big way is important. Being able to have transparency is important. Being able to make sure that you're one of many who are concerned about the risk that you're taking in your asset management strategy. Predictive maintenance can get you there, but it takes time. It takes effort. It takes a little bit more push than you would normally see from what you would find in a computerized maintenance management system of old. It's something that would be just concerned with work management functions. If you look at ways in which you can start to be able to record this, incorporate key performance indicators. In EAM, we have built this into the logic of everything we do. After all, you can't manage what you can't measure. If you don't have a way in which you identify where you're at and then identify improvements to it or declinations to it, you won't know until you can start to trend it. Equipment failure trends. These are things that are important in predictive maintenance measures. These are input variables into understanding how assets behave. These are input variables in being able to predict when an asset's going to fail. With the condition data that you get now from monitoring systems combined with failure trends, solution codes, reason for failure outages, different types of elements that are in the historical set of EAM, you can even get to the point where based on the operation as consistent, or perhaps the operation as consistent with an environmental condition, it's going to fail down to a certain minute amount. It's impressive. It's things that we've always wanted to be able to get to, and with the opportunity for the data sets that are out there, we can see these now. The idea is to be able to take that information, incorporate a predictive measure so where you can be able to plan for failures. You can plan for opportunities for improvement is more available now than it ever has been. And the reason for that is, as Tom was going over, is a lot of the availability of this information is more prevalent. A lot of the availability of the disciplines for doing this is more prevalent. And a lot of them that in different industries, however, have been outsourced. Some have been insourced. Some have hybrid to understand them, especially in highly technical areas where you have different types of metrology calculations, different types of redundancy calculations, electricity calculations, energy calculations. All these different types of things are brought about to help predict, help understand when an asset's going to fail. After all, if you knew an asset would fail, you knew when, you knew what impact it was going to make to your organization, wouldn't you want to be able to make that decision in a better way, in a bigger way? These are things that we do on a routine basis. Coming up in July is our annual user conference. It is going to be in the Javits Center. This is an opportunity for you to mingle with your closest 6,000 or so friends and viewing what other opportunities are out there in the market. If you get a chance to be able to go visit, we'd love to be able to see you. The remaining components that I have that I'd like to direct you to is to some of the detail that we have out there on the web. There's showcase elements for enterprise asset management. There's Twitter follows. There's numbers to give us a ring, understanding where our blogs are coming from, and of course looking at the solution set that's there. There's a ton that can be made. There's a ton that can be done around the predictive maintenance management environment. But to get there, it does take a clean approach. It does take a methodical approach. It does take a premeditative approach. And if you're going to do that, which you should, pick it on an area that is identifiable, that is relatable, that can be able to be quantified. Tom?
Yeah, that was a great wrap-up. That's our experience too, Kevin, that it's when it comes to predictive maintenance, and one of the ways you can position yourself for success is to make sure the entire culture is ready for it. Thank you for the overview of how software can also impact PDM. With that, we have time for about maybe 4 or 5 questions, and already we're seeing a couple of questions, Kevin, come in. So everyone get your questions ready for Kevin or myself or both of us, and we'll tackle as many as we can in the time we've got. So the first question, Kevin, relates to PDM data interfaces and asset management /CMMS. And the question is, how does this PDM data interface into a CMS such that the maintenance department can make some intelligent decisions about the repairs?
It's a good question. So with applications now, especially with the monitoring systems that are built out now, the information, as I mentioned earlier, is a lot more pervasive and readable. So if you look at this, you're talking about streams of data that come in a flat way, most likely through mechanisms called web services. For us, we do integrations to SCADA systems, project logic control systems, building monitoring systems, onboard telemetry systems, and we try to get that information as best we can in real time. And it's a function of our integration tier that we have in our application called the N4 EAM Web Services tier. We also have integration application tools as well called the Intelligent Open Network. We also have upload utilities. We have different types of mechanisms to script data over. So there's a lot of ways that that data can get into the system. Once you get it into the system, however, it's an opportunity for you to do something with it. N4 EAM has been around for a little over 30 years, and when it was originally brought about, it was a condition system. And the reason for that is we have a table in the system to identify condition. These are things that are measurements. These are things that are meter readings. These are things that could be qualitative even or quantitative measures that are brought in. Once they're brought in, the question then is to do something about it. So you have this plethora of data. For us, we typically start with N4 EAM's components and the data tables that we have, and we basically write an algorithm on top of that to look for an anomaly. When an anomaly is found, then we actually take action on it. We work it through the work management technique. We work it through mobile pushing. We work it through email notifications, SMS, a lot of variety. When data sets get larger, you're talking moving from thousands to billions of data sets, you start to look at different storage techniques. We have built into the cloud and the services that we offer solutions that house billions of data sets. They house the opportunity to be able to write algorithms on top of it with multiple variable points and be able to provide a decision on action as a service to different types of applications like EAM. So subscribing to that data and getting that data at one point was difficult because it was analog. Now it's become digital, which is the opportunity in the Internet of Things. The information is more easily obtained. The next question is, what do you do with it? How do you make sense of it? And coming up with that type of approach not only is a function of a computer science exercise, but it also is an engineering exercise. It's a reliability exercise. So making sense of it all is not as difficult as it used to be from a data capture, but it is more impactful from an engineering perspective because, again, everything must be done on the risk variables that you have for that asset.
Okay. Well, and to follow on that question you mentioned, which is reliability, there's a question about the next steps to take to move from time-based indoor condition-based over to predictive, which is what recommendations do you have to offer for an organization or company which currently does PM, uses PM tool, but is looking towards PDM, and maybe even RCM strategies. And my short answer to that one is that you've got to start somewhere, and surveys like the one that Plant Services did can help benchmark where the successes most easily happen when low-hanging fruit is. We see a lot of applications of PDM on rotating equipment, on electrical systems. So I would, when it comes to what to do next, those kind of projects are often very quick results, which can be communicated throughout the company. Kevin, what kind of advice would you give this person about how do you move to PDM and maybe even RCM?
I go back again to the identification of the risk that's going in, or going into some of the variables to maintain that asset. Many times, people will go in to make the move. I apologize, go ahead.
No, I was listening. Sorry about that.
No worries. Sometimes people make a decision not necessarily because of the risk that it presents, because the asset they could be running good. It's the question of the cost elements to it. So energy, man, if you look at your energy budget that you have, the amount of money that you outflow on water, air, gas, electric, steam, those types of variables can be extraordinarily expensive. So if you're looking to make a move and why you should do it to predictive maintenance, perhaps it's that. Are you making decisions on how to manage that asset with all your variables in play? Are you making them based on energy? Sometimes you're not. So the largest cost element that you have to impact that asset, you may not be making the decisions with that information at play. I do that sometimes with my vehicle. With my vehicle, one of the biggest things I want to be able to slow down is the amount of money that I put into the gas tank. If I understand what the miles per gallon is, and I start to pay attention to how it goes up or how it goes down, I can make a decision that can help impact that. The same thing you could do with your own pieces of equipment. You know it should be running in a certain efficiency, and as it goes away from that, you're paying more in energy. That's an opportunity to be able to impact and make a move and make a decision on going to a predictive model, because you can be able to reduce cost in a different way and make better decisions about the assets, so the longevity of it is going to be there and the return on asset will be seen.
Well, we've got a question on return on asset. How do plant teams typically value and justify investments in PdM programs? And I know, CMMS can be used to drive that. Kevin, you want to take that one first?
How do they justify return on assets? Well, again, it goes back again to some of the risk variables and some of the cost elements. I apologize for going back to that same topic, but the justification is going back to making sure that you're operating the equipment in a safe way. You're getting out the asset what you need, and being able to push the capital planning request avoidance even further out. Sometimes in environments, that's a good thing. You need to be able to have a situation where the investment that you make, especially on multi-million-dollar pieces of equipment, gets everything out of it that you can. It gets the right production quality. The overall equipment effective rating is staying high. The amount that you invest from a CFO perspective is something that you want to be able to see a high ROA number. And you can get there, but it takes a large amount of effort and focus to make it happen.
Okay, yeah, that echoes what I was thinking too, which is that sometimes these PdM programs can take time to really take hold, and that, let's say you want to give a 6-month update over a reduction in unplanned downtime, or a 12-month year-over-year sense of avoided costs or unplanned downtime. I know some plant organizations are more receptive to avoided cost figures, and some will look at them as sort of imaginary. So, yeah, what you're saying about capital expenses, some of the numbers that I've seen are more successfully linked back to those capital expenses are increased productivity, thanks to reduction in unplanned downtime. If it's tough to quantify the cost of lost business to downtime, and not enough people have that number, but if nothing else, you can say, yeah, look for the increase in productivity on the asset you're focusing on, and start with that number, and then move into other areas.
Another component, just to scale on that a little bit, Tom, is the question and the struggle, the fight that you always have with a CFO's organization to understand what the budget needs to be for capital planning requests. Mm-hmm. You want to make sure that you're asking for the right things for the right reasons with the right data sets. When you are doing predictive maintenance, you're bringing in quantifiable information. You're bringing in even qualifiable information. These are data elements that you cannot argue. Once you get to the point where you're tracking it well, you also impact the ability to make decisions about replacement, about disclosure, about decommissioning, about refurbishment, about recommissioning than you couldn't do before. And that in and of itself is a value.
Yeah, that you're driving home that point that really, once you move into proactive especially, you can refocus your group's, the perception of your group as a profit center rather than a cost center. And really the success stories tend to align with the company's business goals, as you pointed out. But you first have to know what those are, and then align your programs there. Yeah. We got a good question about security. If you don't mind tackling that one, I'll read it off. How secure is the data that's being stored in the cloud? And what protocols are in place to prevent unauthorized personnel from accessing data or asset control?
It's a good question. This was going to, I believe, one of your points of your market analysis. You're finding out that people are still hesitant to move things to the cloud because the data is not secure. This is a good question for your vendor. So if you get an understanding of what your vendor does in the cloud, how they do it in the cloud, what types of tools they use in the cloud, you'll get this answer very quickly. If you look at the approach that we've had, our partner in the cloud is the Amazon Web Services team. And to get an idea of access, these are things that we go through ethical hacking of our own. We go through outsourced approaches for security review. We go through security hardening techniques, and we also have elements that are brought into routine reviews for our own communication. So we bring about, as an example, a secure socket layer. We have a lot of HTTP connection opportunities, so that means to be secure. Different certificates get modernized, they get changed. Back-end systems, so you look at our front-end application is web client. We have a database that's run on. The access to the web, to the back end of the system is not available from the front end at all. Looking at the people who are authorized to access that data require certifications, require permissions, require administrative review. So there's only certain people that can access that. And then on top of all of that is if it's a vendor that has been doing SaaS for a while, they're used to being audited. Audit them. Ask them. Give them to get you proof. Give them to get you a report. What is the process you have for security audit? Have you written it down? If they have experience in this environment, they have a policy. They have it set. They have a routine update. Again, if it goes back to risk, if for that vendor, they're going to host data, a high risk variable is something happening to that data because that is your production. That is your environment. That is your life. You need to understand that it's there. So you better believe that that vendor is going to have something behind it if they know what they're doing. If they don't, then you have another question to bring about. But by design, systems offered in the cloud are typically highly secure.
Yeah, so that's a great point. And if teams need help from IT to ask that question, pull in IT. But I mean, it always helps to have the same question asked from multiple stakeholders in the organization. To chat, ask the vendor. Let them show you what they've got. Kevin, we have time for one more question, and then I'll move to wrap up. And I think it's a good one. It's about the IoT. At heart, it's basic. The question is, what is the benefit of using IoT-enabled PdM? Why use them rather than just sending, say, grease samples to a lab with AI expert systems and algorithms that could help make appropriate recommendations?
Oh, this is a great question. And if you look at the history of what's there, and you just think about the analog to digital movement, if you think about the analog techniques, so just take you back to the day in which PdM was done. So you have an analysis activity that was done, an oil analysis, a grease analysis. You have that information, it comes out to you, and it's a nice little report. It's a piece of paper. When you get that system into a data, or when you make a decision based on that paper, it takes time. It takes days, sometimes more, because it gets stocked up in different people's processes. What happens in that time? Well, you could have different failure events that are because of elements that you could have predicted, that you could have avoided, that you could have known about because of the data that was captured on that piece of paper. When you go into a digital environment, you have another way to do it. So let's just say you're taking that same paper process and you're going to a flat file. Now you have that information, it's available. It needs to be uploaded, so it has to be, someone has to go in and take it. They have to go through a process. They have to make sure it's clean. They have to put it through. You may have gone from weeks to days, but that's not where you need to be. You need to be at the point where you're a doctor with a stethoscope in your hand. You can understand how that asset is with that grease analysis. You can understand where that asset is with that electric power generation analysis. You can understand where that asset is with everything that you can as fast as you can see it. And when you know that, you know detail as it occurs, you can be able to predict failure in a bigger way, a better way, a cleaner way, because if you have the opportunity for this data to be well formed, that paper, that form that was there is now a stream. That data can be cleaned, it can be brought up, it can be segmented, it can be put into the system in the right way. Once that data is put in the right way, you can be able to always rely upon it in that area, in that structure, because that algorithm is going to be built to pull that to be able to predict when that failure occurs. And you can get to the point where because of that predictive history, because of that predictive data set, because of that element, you can be able to not only predict when it's going to fail, but what part's going to fail and where to get that part. Whether it's something you actually print out, whether it's something that you order, whether you get from another place, these are decisions that are going to be easier for you to make. They're going to be more specific. They're going to put your resources and utilization in the right place at the right time because the information is going to be more available to you. Moving from that process of delayed to real time is going to make you a much more efficient operator of your assets.
Yeah, I'm with you. Nothing to add. That is the advantage, which is the difference between human error and real-time trusted data flow, which can be manipulated a lot more easily. So, Kevin, thank you. And with that, I'll go ahead and move to close. I'd like to thank Kevin Price for speaking today and also for our sponsor, Infor, and for everyone who joined us today for this presentation. Within 24 hours, we'll let you know by email when this webinar will be available for on-demand viewing, and encourage you to share it with your colleagues if you found it useful so that they can see the on-demand version. All of the handouts at bottom left will remain available for on-demand viewers with the exception of the full data set in the 2017 Plant Services PdM survey. I'll see you in about 1 more minute to go ahead and download that. The handouts from Infor include a link to the Infor homepage, 2 customer case studies, a video on best-in-class asset management software, and a brochure on Infor EAM. We also encourage you to visit plantservices.com to gain access to even more tools and resources aimed at helping you achieve success. Did you like this presentation? Let us know your thoughts by answering our brief survey that will appear on your screen shortly. Your candid answers are critical to helping us craft future and better events. So once again, thank you very much, Kevin, for being here today.
Thank you, Tom. It was a great time.
And thanks, everyone, for your attendance. Have a great rest of the day.